Hello students, and welcome to the lecture portion that is going to be concerned with protons, neutrons, electrons. This lecture, what we're going to do is we're going to go ahead and try and figure out ways based off of what's known as a element symbol to go ahead and determine the number of protons, neutrons, and electrons in a compound. Okay? And some of these are going to be a little bit easier than others. So, the first question that we're going to go ahead and solve for is to find the protons in a element number. Okay. Now this is an example. This is rhodium, which is a kind of rare element to come across here. It is useful in strengthening a lot of other metals here. And what we're going to go ahead and note here is that this particular compound is going to have, this element box is going to have a couple of zones. The first one is going to be our element symbol, which is right here. This number right here is called our periodic number, or it's also our atomic number. Okay. There are some, usually in most scientific communities, they consider it the atomic number. And then this number here is our mass number, okay? And so if we were going to go ahead and figure out how many protons this compound had, all that we would have to do is use the periodic number, okay? And in this case, the periodic number is 45, okay? So we could safely say that this particular compound has 45 protons, all right? And that's as simple as it can be. Now this goes right back with our periodic table right here. On the periodic table, it's going to put this number up high, but you'll also see that the mass number boxes that you'll get here, it's going to have it down low. So just go ahead and, if you have any doubts, go ahead and compare it to the periodic table, and the periodic table will help you out as well. Now next, what we'll go ahead and do is we'll go ahead and look to find the electrons, okay? And in general, what's going to happen is if you have a compound like this, and you're trying to find the electrons, it's going to be the periodic number plus or minus some electrons here for the charge, okay? And if you see nothing here, then the number of electrons is going to equal the number of protons, okay? So here for this particular one, the electrons equal the protons, okay? So we can safely say that there's 45 electrons. Okay. Now here, if you have an ion, what you'll notice is that in this corner, you're going to have either a plus or a minus, and that's going to indicate a change. Okay. And if you have a plus, that indicates a missing of electrons. Okay. And the plus is going to represent how many electrons you are missing, okay? So if it's plus, and it's just plus all by itself, that's going to equal 1 electron missing. Okay? If it has plus 2, that's going to equal 2 electrons missing. And we can keep going forward and be like, oh, well, plus 2, plus 3, plus 4, plus 5, plus 6. You know, we can go all the way up to 7, theoretically up to 8, but, you know, the thing is that, you know, it's going to keep going on like that, that you could have plus 8. That just means that you're missing 8 electrons. All right, so for this one right here, this one has a single plus. Therefore, we can go ahead and say that the electrons are going to be 44, okay? And then if you ever have to put in the symbol, you would go ahead and hit Control period and then, the negative there. Okay, so that's how you find out electrons in an ion. Okay, the last question is how do you find out neutrons? Okay, and this is where the mass number comes in. Okay, so the mass number is a number that specifically indicates the number of protons plus the number of neutrons. Okay, and we're going to go ahead and put equal here. So mass number equals protons plus neutrons. Therefore, if you have the mass number, you can go ahead and subtract from that the protons, and that will give you the neutrons. Oh, let's spell neutrons right. Let's not spell like George W. Bush. There we go. Okay, so in this case, we have 103 for our mass number. We'll go ahead and subtract from that 45, and we're going to be able to figure out our number of neutrons. And in this case, it should end up being 58 neutrons. Okay, so see what we did? We took the mass number, which is this one, subtracted it from this one, and that's 58 neutrons. Okay, often this will be the one that you're going to have to find for different elements. Okay, so this is one example here, and let's go ahead and work through a practice here. Okay, often in one of these I'll go ahead and have you guys figure out the all three of them in a particular one. Okay, so right here, this one, find the protons, neutrons, and electrons for this element. Okay, so what we'll go ahead and do is we'll go ahead and let's make a new one. And I like to always start with the protons because that's always the easy one. Okay, protons, we go right down here. We have 72 protons. And we're going to go ahead and put a positive there just to help us out. Okay, next we're going to do the neutrons. And in order to do the neutrons, we're going to go ahead and take the mass number, which is 178. We're going to subtract from that 72. And that means that we'll end up getting a total number of 104. No, that's me bad at math. There we go. That's going to give us a total number of 106. We'll put 106N, and then we'll put a not, because the protons have no charge, or the neutrons have no charge, sorry. And the last one is going to be electrons. And the electrons, we're going to go ahead and take a look. We have 72 for the base. So we have a base of 72. And then it says plus 3. Okay? So plus 3. If plus 1 means that 1 electron's missing, and plus 2 means 2 electrons are missing, plus 3 means that 3 electrons are going to be missing. So we'll subtract 3 from there, and that will give us 69 electrons. All right. Now, as I'm going through here, I see that I might want to go ahead and show one more example here. So give me just a second here. We're going to go ahead and highlight. Oh man, that box is terrible. Okay, we're going to highlight this one right here. We're going to Control C, Control V, and let's get rid of this box altogether. And we're going to go ahead and put in a different element here. So we're going to go ahead and put in phosphorus, and I know that phosphorus has a weight of 31 and it has 15, and we're going to go ahead and say that it's an ion of phosphorus, and typically ions of phosphorus end up having an ion of -3. Okay, so this is the last one that we're going to go ahead and do for today. And let me just double check my, yes. Okay. So we're going to go ahead and do the protons, neutrons, and electrons here for this one. Alright, and we'll go ahead and start with our protons. Proton should be fairly easy. That's always going to be our periodic number. Then we're going to go ahead and do our neutrons. And in this case, our neutrons, we're going to do it the same way. We have 31 for our mass number minus 15, which will give us 16. The last one is going to be for our electrons. And in this case, we're still going to have our base of 15. So our base is 15. But notice that this time in the corner here, we have a -3. Okay? Now, if a positive 1 meant that electrons were missing, then a -1 is going to mean that we have extra electrons. So here, we're going to go ahead and put 3 extra electrons. And that's going to go ahead and tell us that we have a total of 18 electrons. All right. So this was one other type of problem that you could see, and I realized that we hadn't done one with a -1. Now, there's one other type of problem, and that's going to be to go ahead and fill in an element box. Okay, with a compound, not with a compound. So we're going to go ahead and fill in an element box, and we're going to fill it in with this information. Okay, so we're going to go ahead and say that we have protons, and I'm going to pick an element here. Going to say we have 50 protons, neutrons. We're going to go ahead and say that we have 68 of them, and electrons, we're going to go ahead and say that we have 48. Okay, so what we're going to do is we're going to go ahead and fill in an element box with this information. Okay, so I'm going to go ahead and grab my old element box to go ahead and help me out here. Because formatting is awful on PowerPoint, you guys should probably all know that. Okay, so here, protons, 50, all right? Let's take a look. Which one of these elements is 50? So we go through, and there it is, 50. Okay, it is 10. All right, so now we know it is 10. So that means that I'll go ahead and come back here. And we know that this is 10. Okay. Next, we can go ahead and fix this, okay? Because we don't have 45, we have 50. Okay? Now we have to go ahead and figure out what the mass is, okay? Because this right here is our mass number, all right? So we'll go ahead and take 50, and we know that our mass number equals protons plus neutrons Therefore, we can put x here equals 50 plus 68, okay? Which altogether will end up giving us 118. Okay, so for our element box, we go ahead and put 118. Now, the last thing that we have to do is we have to figure out our electrons. Okay, and here it says that our electrons are 48. Here, we have 50 protons. So that means that we're missing some electrons. How do we figure out how many electrons we're missing? Well, 48 is 2 less than 50. Okay, so that means that we'll go ahead and indicate, hey, we are now missing electrons, so we'll put plus because we're missing electrons, and then we're going to indicate how many that we're missing, and we're missing 2. Okay, and so this is going through the opposite way and figuring this out. All right, and this is the last type of problem that you might have for this one. All right, I'm hoping that with this lecture you should be able to do all of the worksheet for this current section, and I hope you have a wonderful evening.